All right, so today we're going to be working on the high power section for Wizard Blocks. This board actually is courtesy of the awesome Scott Danesi of Total Annihilation fame. He sent one of these out and pretty much comes as a blank board, and he supplied a couple parts for the high power filter board. For this project, we're actually using a switching power supply to supply all of the, well, really all the voltages in the machine. This one in particular supplies the 48 volts for the coils. Now it can actually supply 48 volts at roughly 12 amps. So it's actually a Meanwell SE648. These actually are very highly reviewed and rated power supplies. So that's kind of what we're using. And an ATX power supply supplies are 5 and 12 volts for the various LEDs and logic boards and things like that underneath the playfield. We're using a PRAC system because it is just beyond reliable. So it's a great system, and if you're ever thinking about building a game, I'd recommend it. So yeah, so that's kind of what we're doing. And pretty much this board here is going to take, it's going to sit in between our power supply here and the actual devices on the playfield that it's powering. And it comes, it actually requires the use of several very large capacitors. These are actually 6800 microfarad capacitors rated at 63 volts, so we got a little bit of headroom. And 4 of them are actually wired on this board so that you have plenty of capacitance, because of course these power supplies are rated at 12 amps, but it's for a very short period of time. So if you're continuously pegging the power supply, power is going to get dialed back a little bit. It causes an awful lot of ripple. So this is actually going to even things out. And this board has a couple of different things on it. It has a fairly useless LED, but basically it's going to warn you whenever it has power to the board. So actually it's not useless. It serves good purpose. If it's lit, don't mess around, because again, ultra high capacitance here, and again that high amperage going through you, it really wouldn't be a good day. Got some diodes on here just in case things get swapped around. You're not going to be blowing these up in your face. That's a good thing. Safety, yay. And then we've got let's see, the high power LEDs, resistors for the LEDs, because again the LED is actually powered right off of the 48 volt supply, so we got to drop that down quite a bit so that we don't launch these little LEDs into orbit. We got our headers and of course IDC connectors. So yeah, now we're getting the soldering iron all warmed up, so let's go ahead and get it going. Alright, so we got everything wired up. Got the power supply feeding in 48 volts into our board, and it's going through the filter board here. You can see our LED is lit up, and we're getting about 47.4. With some resistance here from the board, we can actually connect right to the power supply, and we're getting about 47.9. So we might have to adjust the dial on the power supply a little bit, but I actually think this will work out wonderfully. These caps will actually hold quite a bit of charge, so we do have to be careful around those, but I think this should actually work in the machine very nicely. And as a matter of fact, if we actually shut off the power supply, it will actually discharge very, very, very slowly. There's not really any load on here, but yeah, so these everything seems to be working just fine. So again, big thanks to Scott. This board I think is going to be a real big help and really keep things going strong in the machine. So that's today's update, and we'll be back at it tomorrow.